balanced chemical equation, you can see the relationship that exists. That is what we normally talk about when we say we're dealing with what? Stoichiometry. We're looking at the stoichiometric relationship that exists here, both in mole, in mass, and what? In volume. So now what I'm doing here is to solve this question based in mass, because we are given mass. We've already gotten the mass to what? To volume. This is the type of stoichiometry we say is what? Mass to volume relationship. That is what I'm using to solve this thing. Now this is mass to volume. Now the mass we are looking for is, we want to know the volume of carbon 4 that will be liberated if 5.5 grams of this sodium triisocarbonate is used. So what we have, 5.5 grams of what? Sodium triisocarbonate will give us 22 all over times 5.5. 22.4 divided by. So what we have here, what you have is approximately 1.162 tm cube of what? Carbon 4. Now, if you want to convert it to cm cube, that will be multiplying by, you multiply by what? 1000. Let's just go by that, times 1000 cm cube. So what will multiply by 1000 cm cube? So what we have will be equal to 1162 cm cube. That is what will be liberated at the end of the reaction. So the next one we're looking at now, it says we are calculating the percentage of sodium triisonitrate 5 in the mixture. Now, sodium triisonitrate 5 in the mixture. Now look at it. We have it in 25 into in 500 cm cube. Dissolve in 500 cm cube. So what we are going to do now, you need to find out what we have in 1000 cm cube or 1 dm cube. So we know that concentration C is always in grams. Concentration in grams is always mass over what? Volume. Where this volume must be what? In dm cube. The volume must be in dm cube. So the first thing we do, the volume will then be 5. Today we are going to be looking at the titration part of the exam we have at hand, and in this question what we have is the mixture of two compounds. Let's just read through what we have. Say that there is a solution of triisonitrate 5 acid containing 0.109 mole per dm cube. B is 4 grams of a mixture of sodium triisocarbonate 4 and sodium triisonitrate 5 dissolved in 250 cm cube of distilled water. So this is the equation of reaction of what really happened. You can see that the triisonitrate 5 did not show up here. This is just because sodium triisonitrate 5 here is more like an impurity, because impurity does not take part in a chemical reaction. That's what we are meant to understand. So since the impurity did not take part in this main reaction, so there is no need. We look at it now. We have triisonitrate. That means this triisonitrate 5 acid will not have any effect on it. It's more like what we have here, the product. Just this will triazonitrile will only add up to this, the mass of sodium triazonitrile that is present in the total reaction. At the end of the reaction, it will just increase the volume of this that we have. So the titration we're looking at now is just based between sodium triazocarbonate and nitrate 5 acid. So this is what we have. The other process, I have to skip that because of space. That is the process of the procedure, how you do your titration, which I did not include. But what I really want to remind you here is that I use 25 cm cube volume of what? Pipette. That is what I use, even though I did not state it there. So it's very important that you note that in your own case, you might decide, depending on what you have, 20 cm cube or 25 cm cube is allowed. So now the first thing we are going to do here is to get the average volume of A used. Average of A used will be, I take this to the first and second titration. What we have will be 23 points, no, 8, sorry, 80 plus 23.80 all over 2. So if you make it all over 2, 23.8, we'll have 4, 6. That will still give us 23.8 cm cube. That is average volume used. So with this average volume now, we are going to be looking at, the question said, from your results and information provided, calculate concentration of sodium triazocarbonate in mole per dm cube. Number 2, concentration of sodium triazocarbonate in gram per dm cube. And the third one is volume of carbon 4 liberated at STP. Now the last one is percentage of sodium triazonitrate 5 in the mixture. That is what we are going to be finding out here. We're going to be calculating them. Now we have the volume of this already given to us. So the next thing we're going to do here is to what? Go into this calculation, the first calculation here. So the first one we do here, remember, we normally use our, this seems to be the simplest formula, sorry, all over equal to so where this is concentration of the acid, that's why we're using this. The volume of the acid, this is the volume of acid, which is 23.8 cm cube. Concentration of this is what we are looking for. Concentration, pay attention to this. This is what we are looking for, and the volume already is given to us, which I told you is what? 25 cm cube. So what we're going to do is to substitute every other values. We substitute them, and this other one is mole ratio. The mole ratio we have here, for A we have 2, for the B we have what? 1, because there's something here, it's automatically 1. Remember, in the coefficient here, this coefficient is what? 1, because 1 times whatever we have there is will give us the same thing. So now let's substitute every value. The concentration is 0. Times volume, which is 23.80 cm cube. Concentration of B in mole per dm cube is what we don't know, but the volume is 25 cm cube, equal to mole ratio of the acid is 2, mole ratio of the triazocarbonate is 1. So what else are we going to do now? What we're going to do is to cross multiply. If we cross multiply it, I think I can take here for now. Alright. So if we cross multiply this, what we have will be 25 times what 1 times CB equal to 0.109 times 23.8 times what 1. All of them give us, making CB the subject of the formula, we will have 0.19 0.109 times 23 times 0.8. 1 is will not make any difference here. We have is it 1? Wait, this multiply that. This one should be 2. Multiply the up. Note, I even skip something here. Multiply this one will give us 2 here. That means here should be, let's just make it up. This 2 times 25 will just give us 50. So we'll leave it there. So the next thing we do here is to divide everything we have. We'll do that times divide by 50. So what we have is our final volume answer here. Our final answer is CB is equal to 0.052 approximately mole per dm cube, mole per dm cube. So that is what we have here. So we're able to get the word concentration of sodium triisocarbonate in mole per dm cube. The next one we're going to be doing is concentration of sodium triisocarbonate in gram per dm cube. Now we are given the relative molecular mass, which is this, which is 106. So for us to get that thing done, remember we know that mass mole is equal to mass over what? Molar molar mass So if we cross multiply this, we have mass equal to mole times what? Molar mass. So what do we do next? We're going to substitute our average value there. Don't really want to clean this so I won't forget question. Let me remove the ones we have done. So we substitute, we have the mole here, we have 0.0252 times the mass, which is 0.106. Multiply it, we have times 0. What we have here is then equal to 5.499. Okay, you can just approximately 5 gram per dm cube. That is what we have. We have 5.5 gram per dm cube. So this is, we have succeeded in getting the second question. The next one we're looking at is volume of carbon-4 liberated. When we talk about the volume of carbon-4 liberated, now I'm going to be taking you to another phase of the question. Now, if you look at this chemical equation, you find out that 1 mole of sodium triisocarbonate will give us 1 mole of carbon-4. Now, if we want to work it the other way around, we want to work from grams, we look at it from grams. If you're looking at the grams now, because what we produce, the mass present is what will determine what we are going to produce. Note that since we have 5.5 grams, that will determine the volume of carbon-4 that will be liberated at STP. So here now, from balanced chemical equation, we find out that sodium triisocarbonate, we have that 106 grams of sodium triisocarbonate 4 will liberate what 250 22.4 dm cube of what carbon 4. Now we know we are giving molar volume, so that's what might ask, why am I using 22.4 dm cube? Is because every gas at STP contains this, and whatever you have in a balanced chemical equation gives you what happened in ideal environment or standard environment. So in balanced chemical equation, you can see the relationship that exists. That is what we normally talk about when we say we're dealing with what? Stoichiometry. We're looking at the stoichiometric relationship that exists here, both in mole, in mass, and what? In volume. So now what I'm doing here is to solve this question based in mass, because we are giving mass. We've already gotten the mass to what? To volume. This is the type of stoichiometry we say is what? Mass to volume relationship. That is what I'm using to solve this thing. Now this is mass to volume. Now the mass we are looking for is, we want to know the volume of carbon 4 that will be liberated if 5.5 grams of this sodium triisocarbonate is used. So what we have, 5.5 grams of what? Sodium triisocarbonate will give us 22 all over times 5.5. 22.4 divided by. So what we have here, what you have is approximately 1.162 dm cube of what? Carbon 4. Now if you want to convert it to cm cube, that will be multiplying by, you multiply by what? 1000. Let's just go by that, times 1000 cm cube. So what will multiply by 1000 cm cube? So what we have will be equal to 1162 cm cube. That is what will be liberated at the end of the reaction. So the next one we're looking at now, is said we are calculating the percentage of sodium triisonitrate 5 in the mixture. Now sodium triisonitrate 5 in the mixture. Now look at it. We have it in 25 into in 500 cm cube, dissolved in 500 cm cube. So what we are going to do now, you need to find out what we have in 1000 cm cube or 1 dm cube. So we know that concentration C is always in grams. Concentration in grams is always mass over what? Volume. Where this volume must be what? In dm cube. The volume must be in dm cube. So the first thing we do, the volume will then be 500 divided by 1000. We have 0.5 dm cube. And our mass there, the mass given to us there is what? 4. So what we do here is, then using this relationship, we have concentration in gram will then be 4 over what? 0.5. That will give us, let's see what we have. divide by 0.5. We have 8 gram per dm cube. Since now we're looking at it in dm cube, that means 1 dm cube will contain, the mixture contain 8 gram. So what do we do now? We're looking for mass of this that's present, percentage mass of that. So before we can do that, we need to know the mass of this very triazonitrate 5. So we have the total mass of the two compounds in what 1 dm cube. But now remember, you can still remember that our mass of sodium triazocarbonate 4 we have in this is what? Sodium triazocarbonate 4. You still remember, I think it should be something like 5.5 gram per dm cube. So to get the mass of this, because before you can get the percentage of this in the mixture, that means you are going to know what's the total in 1 dm cube. So now what we do here is this is, I think I can bring here. This question has registered in my mind. My brother can bring these ones. So what next? Then mass of sodium will then be 8 minus 5.5. That will give us 8 minus 5.5 minus 5.5. We have 25.2.5 gram as per dm cube. That percentage now, percentage of it in the mixture will then be, remember, we normally do it just like this is the mass in question, over what? Total mass of what? Mixture times 100 over 1. So the mass we are looking at is what? 2.5 over what? Total, which is 8 times 100 over 1. So let's see what we have. Divided by 8 times 100. So what we have here is 31 points. I can make it that's 31.25, which is approximately, we can say is 31 points. Okay, let's go by this. We are 31%. So this is what we have, and we've come to the end of it. But then the question might come in any other way. There are some other things they may also ask you to look at, but this is the possible one I think that will come in. But thank you so much for being part of this class to this moment. And if you're joining for the first time, I want to encourage you to subscribe, and share. That's one of the ways you can, encourage us to do more. And then if you have any question at all, please endeavor to leave it in the comment section. I will always look at it and answer your question. So thank you so much.